As it turns out, when I was a graduate student and I went to USC to work, this theory was just kind of coming online, the whole idea of natural fluorescence. And Dale Kiefer, who's an oceanographer at University of Southern California, an incredibly brilliant oceanographer and brilliant mind. I was his graduate student, just lucky enough to get hooked up into his lab. He gave me the task of trying to compare rates of natural fluorescence, so this red fluorescence glow, with how fast plants were growing using the C14 method. The question was, can we use natural fluorescence, this red glow that we're detecting in the water column, can we use it to estimate how fast plants are growing? Because, think about this, if we could just lower a sensor in the water column and get some idea of how fast the plants were growing, kind of like Scotty on a foreign planet using a tricorder or Spock or one of those guys, it's much easier then, and certainly has much more capability in the ocean than having to take out water samples, inoculate them with C14, put them back out in the ocean, bring them back, filter them, put them in a simulation counter, calculate productivity. If we can get an instantaneous measure of how fast the plants are growing, it certainly opens up the kinds of biological measurements we can make, and also improves our ability to understand what's happening in the world ocean and what kinds of conditions affect primary production and photosynthesis in the ocean. So that was my job when I went to USC as a graduate student. We were also lucky enough to be approached by the Cousteau Society. Jacques Cousteau was the inventor of scuba and one of the first people to produce underwater documentaries for television. And for those of us who grew up in the 60s and 70s, he was our god. You know, he was the oceanography god in a sense. And although he's been kind of criticized for some of the things that he's done, and some people say, well, he wasn't a really scientist, didn't matter to me. He was my hero growing up. And we were lucky enough, or I was lucky enough when I was a graduate student, to be approached by the Cousteau Society, and they asked us if we wanted to go out and do some experiments on their famous ship, the Calypso. And so we jumped at that opportunity. This is Dale Kiefer. He's, again, optical oceanographer, ecologist, modeler at USC, where the world-famous Trojan football team plays. And he was my advisor. He's the one that really developed the theoretical foundation for the relationship between natural fluorescence and primary productivity. And it goes something like this. This is a slide from my thesis, but basically what we're looking at is fluorescence being a proxy for, or a tool for measuring productivity in the same way that measuring oxygen is, or measuring C14. And so in my case, what I wanted to do was compare natural fluorescence measurements using what's called a natural fluorescence detector, ignore that for a moment, and how much carbon was being produced in C14. And the idea then being and that there is a predictable relationship between rates of natural fluorescence and rates of photosynthesis, rates of natural fluorescence being measured by an electronic instrument that measures the red light, and rates of photosynthesis being measured by the C14 method invented by Steeman Nielsen. Again, I was lucky enough to be invited aboard this ship. It's a wooden vessel. It was a former minesweeper. Used to be moored up in Seattle was its home port, and Cousteau bought it and re-outfitted it, put a helicopter pad on top, put a submarine underwater viewing chamber on the hull here, put a winch on it, a little diving saucer, and this is the Calypso off the coast of Tahiti, where we went and did some of our first work. Now, I actually was able to make 2 expeditions with Cousteau. One was a trip from Tahiti to New Zealand. That was a 3-week trip aboard Calypso, where we made a series of measurements. And another trip the year later, in December, just working in and around Moorea and in August, working in and around Moorea and Tahiti. So what you're going to see here are some slides from that trip, we're going to do a little travelogue here by way of trying to explain natural fluorescence and the kinds of measurements that we made. But you'll see 2 different trips. One was a set of experiments done in December of 1986, if I recall correctly, from Tahiti, New Zealand, and another set of experiments were went in August of 1987 back to Tahiti and Moorea to make some other measurements. So this is probably in the second trip, but here you can see beautiful tropical skies, beautiful ship, and sort of the kinds of opportunities that you could have if you decide to choose a career as an oceanographer. Well, on this first trip we traveled through the Pacific Ocean. This is from the bow of Calypso, and I have to say this blue water that you see here, there used to be an Arizona iced tea bottle that was kind of colored this sort of cobalt blue, but this is the bluest water I've ever seen in my life. Really, it almost hurts your eyes. It's just like pure seawater. There's very little in it. And as it turns out, we got to go swimming once off the ship in the middle of the Pacific. It's nice and warm and tropical, and we're swimming in this water. It's just crystalline blue. There's a few jellyfish and things in it. And suddenly I hear a ruckus up top. I hear somebody shouting, "Recount, recount," and I didn't speak much French at all, so I didn't know what that word meant until somebody shouted "shark" in English. Now, you can imagine that in an area like this, which is basically a biological desert, that fish are usually hungry, and sharks, if they hear anything in the water, and they can hear for miles away, they're going to be attracted to it. So, fortunately, I didn't even think about it, but fortunately the men aboard Calypso posted a man on watch to look for sharks, and they yelled for sharks, and so we quickly got back into the boat. But it turned out not to be a very dangerous shark, but it was a little bit of excitement in the middle of the South Pacific Ocean nonetheless. Well, here we are on this trip taking water samples. Here you can kind of see the outline of a water sampler. You can see the kinds of conditions that we had to endure, and you know, it can be either beautiful or it can be rough and crazy, and we had both kinds of weather on this 3-week trip. This is Dick Murphy. Richard Murphy is Vice President of Science Education with Ocean Future Society, which is Cousteau's son, Jean-Michel Cousteau. He has his organization now that also is making underwater documentaries and promoting ocean conservation and stewardship of the oceans. And Dick Murphy was a graduate student at USC, and he's the one that invited us to come aboard this trip. But here we are making some measurements and collecting some water, and those water samples are then going into these bottles, which some of them are clear, some of them we've wrapped screen around, and some of them we've made quite dark. Now the idea here is, if you can't actually take measurements by throwing a buoy over in the water, the next best thing is to simulate the different light levels. So here we're simulating light intensity at the surface, here we're simulating light intensity a little bit deeper, and here at the deepest depths. And because we weren't able to use radioactive carbon on board Calypso itself, in this set of experiments we tried the stable isotope carbon-13. In short, it turned out to be a disaster. The carbon-13 solution that we're using didn't dissolve properly, and really I probably didn't know what I was doing to the extent that I should have known what I was doing. So all these experiments, though they look nice here, this nice in situ on-deck incubation, this nice on-deck incubation, simulated in situ on-deck incubation, was a complete failure. We also tried some experiments where we did put bottles out on a set of floats. This is a radar reflector, so that if this gets away or we get further away from it, we can try to find it on radar. Here you see the float from Calypso, but on this float then is a series of bottles in which we have inoculated them with C13 in this case, and again, as I said, unfortunately it turned out to be a bummer. It didn't work. Well, here I am on the bridge of the Calypso with a man called Mr. Tahiti. His name, I believe, was Mopti. Again, this is 1986. I looked quite different then. And, yes, you saw it right. I had green hair. And if you email me, I'll tell you about that green hair sometime. But it was an interesting side story, but I don't want to get sidetracked in our story here.